Don't ask me why, but the book says, if you look at it there, a rational function has a variable in the denominator. Said slowly and articulated. Has a variable in the denominator of a fraction. You will recognize this after I show you. The parent function of this, which means, you know, when we do y equals x squared, y equals whatever, is this. Y equals 1 over x. That should look kind of familiar to it because it is what? Does anybody know? We just did it not very long ago. Christine?
Y equals 10.
Right, which is the, what did we call that? Inverse variation. Inverse variation is what it is. And I actually did graph this for you. The graph of inverse variation, does anybody remember what the graph of inverse variation was? Sammy? It's kind of a cool looking thing. More than that though, it's that and it's, yeah. Inverse variation graph is this. Wow. And this. Wow. Okay. They would be this corner and this corner if this was negative, but it's not. Now, lest you think that's it, and we will graph one on the calculator here in a second. Lest you think that's it, here is what you must write down. That's the basic simple parent function. This is the more complicated, more exciting one. Y equals A over X minus B plus C. Don't let all of those numbers fool you, because still when you graph whatever this thing is, because there'll be numbers in for A, B, and C, you will still get some sort of this sort of thing, or whatever it is, at some place on the graph. The problem is, where does that thing happen? It's a little like when you graph, you know, the absolute value of x minus 3. When you did that, you know that the graph has the v in it. It's the rest of the stuff that tells you where the v is located. In this case, the v was what? 3 places to the right, like this. Same thing here. And in this, we have a special name for these places. Let me go back here. When you graph these rational functions and you do these little swoopy things, okay, they will always approach some point but never cross it. For example, this one approaches the x-axis. It will keep getting closer to it, but never, ever, ever, no matter how big you make your graph, will it ever cross or touch that axis. Same thing with this. When that happens, those things are called, it's a hard word for me to say, asymptotes. It's hard to put those letters together, much less putting those letters together. Asymptotes. Okay. They have the x-axis is the horizontal asymptote, and the vertical one, the y-axis, is the vertical one. And that's what you are looking for. Let me get the exact. A boundary line is what it calls, that it approaches but never crosses. Boundary line. And the reason for that is, if you look at this function here, okay, x could never be what number here? 0, because that would put a 0 on the bottom of the fraction. You can never have that. So x is 0, well, x is 0 right here. So it'll come close to the y-axis, but it'll never cross it. Same thing is true. I can't have 0 for y. Why? Because 0 equals 1 divided by what number? 1 divided by what number is 0? You can't do it, no. You can't put 1 divided by 0, because that's, again, not something you can do. You know, if you want to think about it like this, you could make this a fraction to cross multiply. 0 times x equals 1. 0 times what number gives you 1? You can't do it. So neither x nor y can be 1 in that case. Well, over here is the numbers you can't have when it's got all this complicated stuff here. And I don't have mine. I'll just do a circle. Just write this down. Take a little note here. The vertical asymptote, where did I come up with a different name? I just can't put those letters together. Is when x equals b. And the horizontal one is y equals c. That'll make no sense to you at all until we do a problem. None whatsoever. And if it does make sense to you, you're smarter than I suppose. But once we do it, you'll say, oh, that's very easy. Notice the letter A doesn't appear there anywhere. There you go. Got that? This is what that means, boys and girls. You'll like this. Let me give you an equation. Let's say y equals 3 over x plus, nope, I'm not going to do that, x minus 2 plus 1. Got that? See the A, B, and C numbers? Here is the quick graph of that. First thing you do is try to figure out what the letter B is. Well, B is the one that's x minus something, so the letter B is 2. So where x is 2, you have to do this. 1, 2, boom, 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 you draw a dashed line. Because that is the vertical asymptote. Mr. Schmidt, do you need these kids for pictures?
Whenever you're ready.
Well, let me just throw this. We're just about close to.
I'm learning too.
Okay, the letter C, ladies and gentlemen, is the y asymptote. So where y is positive 1, you do the same thing here and draw your little dashed line. And these two lines, the vertical and the horizontal, form those boundary lines that you can just draw your little pretty little crooked little lines that go like that. So really it's just this number and this number that tell you where that whole thing shifts to. Evan loves it. Yes, Evan.
What's the point of the 3?
The 3, I believe, and the 3 you could sit down and do it, but the 3 is probably going to give you whether this is a really narrow, close to the line thing or a little wider out thing. Right now, I'm not too concerned about the 3 because you're getting close to where it's at here. Technically, the book tells you that you're supposed to, after you find those asymptotes, you're actually supposed to make a graph and plot some of those numbers in there, but at this point, I don't think we're going to actually do that. Again, I might let you do a calculator or something like that. But first I believe we need to take some pictures.
What's an asymptote?
Well, it's a boundary line that the graph will come close to but never cross. That's a good question.